Welcome to a lesson with Dr. Powell. Let's take a look at another way that we can complete the square. All right, so suppose we have a quadratic. Suppose this is a function here. I'll just write it as y equals. We can take these first two terms and just factor out a 3x. So you notice we're going to factor x out, not just the 3. So 3x, and then we have x plus 10. Notice that what we're looking at is a shift up 2 of this. How does this graph? I mean, that crosses the x-axis at when this factor is 0 or when that's 0. So it's 0, negative 10. And the vertex is right in the middle of those guys, right, by symmetry. So it's going to be, crossing, and it's going to be right in the middle. So we know that the vertex x value is going to be negative 5 just right off the bat. So we can write that down. Okay, so the vertex is going to be at negative 5 just by looking at that quickly. Now, notice we're saying we're taking that middle. Now, what happens when we plug in that x value into the function? We're going to get out the y value of the vertex. Let's just think of a quick way we can calculate that. I mean, we can just throw it in any way we want to do that. But just for intuitive sake, what's a quick way of thinking about even just that calculation? If we were to plug in negative 5, into here and here, we're going to get either plus or minus 5 here and here. Over here, we're going to get, in particular, we're going to get plus 5. Over here, we're going to get minus 5. Whatever we do in every situation, we're going to have the opposite. We're going to have the same thing, the middle x value, or the vertex value, either plus or minus here, but it's going to be opposite here or there. In some sense, we can just kind of think, okay, take that and square it, and then just take its negative, all right? And multiply it to that 3, whatever that coefficient is sitting right there. So 3 times the negative of whatever that square is, and then you still have the plus 2 out here. Just add it on, and there you go. So here we have 3 times negative 25. That would be negative 75 plus 2, which is negative 73. So we get negative 5 comma negative 73 is the vertex. How can we use that to complete the square here? Well, we just kind of think backwards. I mean, to get standard form, we think, okay, we have a 3. We usually have x minus whatever the x vertex value is. So here we'll have x plus 5 squared. And then this negative 73 is just right there. We just completed the square. Okay, by determining what the x value is of the vertex and what the y value is of the vertex. Along the way, we didn't even ever really think about putting things into square chunks at all. We just kind of used a basic symmetry right here of a graph being shifted up to, and then we used the fact that in this factorization, since we were looking at a middle thing right here, and this is like 0 and that guy, when we plug it in, we're going to get the number times its negative, or its opposite sign. So we have negative a square, and that's always going to be a negative right there. And then just multiplied by whatever this coefficient is right here, and then just add that number that's still hanging off. So it's a pretty fast computation, and we can get to the completed square form here. This is not the only way to complete the square, but it's kind of fun to see different ways.